Hello, this is Dr. Michael W. Berry, and I'll be offering Computer Science 370 this semester. The lectures for the semester will be provided online, hosted on iTunes U, and the instructions on how to access the videos will be provided on the Blackboard account for this course. All the questions and answers related to material in the course from assignments, and lecture material and any other general questions will be handled through the piazza.com page for Computer Science 370. So make sure that you are registered on that. And again, you can send me email if you need access to piazza.com. You should get an invitation email on how to join that. The book we're using for this course is called Numerical Methods in Engineering with Python 3, as you see on the screen with the big green snake. It's written by Jan Kusalis, and the publisher is Cambridge University Press. The book is available from the bookstore, alternatively from other book vendors online. And what you're seeing on the screen is actually the ebook version of it. ebooks.com provides an electronic version of the textbook with what's called an Amigo Reader interface for it. It's very nice, as illustrated here. Here's the Contents tab. Lots of nice features are available in terms of immediately going to the material of the book that you need to look up things, make bookmarks and notes, and so forth. Very, very nice. I'll be using the ebook version to supplement some of the lecture notes and materials as we go through. Let's talk about the notes. So I'm going to bring up the first set of notes here for the course. All the lecture notes will be provided on Blackboard for you to download and to follow along and annotate, perhaps, as I provide more information than what is on the slides. I'm trying to use the slides as outlines for us to discuss and to as we work through all this material. So I'm going to go ahead and get started and cover some of the intro material out of Chapter 1. I won't cover all of Chapter 1 in this video. I'll try to keep these videos smaller for download purposes and try to break the material up very easily so you can easily go back and review very specific topics. Python is a wonderful language that I think you'll enjoy learning this semester for scientific computing, but also to use for other projects and for future work, perhaps even in your senior design. So it's an interpreted language, and a great reference website for the language is indicated on the screen here is www.python.org. That has general reference information about all the different libraries and functions that are available. And most of the material, most of the functions will be described in the lectures or in the book, but it's nice to know that there's a place on the web that you can go for a complete reference. The language does have an editor that's available that you can interactively create programs and execute them and change them and debug them, and it's called idle. I don't particularly use it. I'm more comfortable just creating script files with the commands and then just executing the script files. Your TA will show you and demonstrate idle, but it will also show you how to create script files and run Python on your desktop or laptop computer. You will need to make sure that you're using NumPy, which is a particular scientific library provided with Python. It has many functions that we'll be using through the semester, and again, we'll make sure you know how to access that. We are using Python 3. There are earlier versions of Python, but you'll want to make sure you're using Python 3. And so if you're downloading, if you don't already have Python, make sure that you are accessing Python 3, some version of Python 3. And again, what's indicated here at the very end of the file here is the fact that script files can be used, which contain the commands to be executed, rather than running Python interactively. And if you do that, then you have to tell the operating system, Linux operating system, for example, that you are executing a Python script. And so the first line of that script file would need to be a pound sign followed by the exclamation, and then the Unix path, the Linux path, to the interpreter. And this is an illustration of the path on one of my Mac laptops in terms of where Python, in this case I'll be running 3.3, exists. So again, your TA will demonstrate how you can run script files, and I think you'll find it very convenient and very natural in terms of how to write and execute programs. So starting the core material in Python, this is section 2 of the first chapter of the book, starts off by describing basic variables and data structures that make this language a little bit unique to maybe what you've seen in C and C++ and Java and perhaps some other scripting languages. First of all, the most important thing is the nature of variables. In Python, variables are dynamically typed, and you have to pay attention to how you define literals. So for example, first thing I want to point out is that what you see on the screen in terms of these greater than signs, that's indicating a prompt for the Python interpreter. So that's what the 3 greater than signs mean on all of these subsequent slides. And then what we're doing to start off with is just very simply defining a variable A to associate with memory to store the integer value 1. So anytime you type an integer in Python, the interpreter automatically interprets that as an integer, because that's really what it is. So the memory associated with the variable A now is storing an integer. The other thing I want to point out here is notice that the syntax here, I've indicated here that I have a pound sign followed by some text. That's a comment. So in your script files or even in the interpreter, if you were to type a pound sign, it would immediately consider that a comment and not execute anything after that. So it's just a nice way of annotating your file. And again, we really do like for you to comment your code. So in this particular example, we've stored 1 in the memory associated with the variable A, and it's an integer. And then if you were to execute the print function, and the syntax is just to print followed by parentheses and then whatever you want to print, the variable there. In this case, it would do pretty much what you would expect. It would print the integer 1, because that's what we've put in that variable. But then notice what happens next in the interpreter. It's an illustration of dynamical typing, because A originally was an integer, and now what we've done is arithmetically added the value 1.5, which is clearly a float and not an integer. So what is A now? A, of course, now is a float, because we have completely changed the meaning of A, that now it has a fractional component. And of course, if you were to print what A is, then you would get the value 2.5, which is clearly not an integer. That is clearly a floating point value. So this is an example of A has originally defined as an integer by defining it to be the literal 1, and now it has become a float. So this is an illustration that variables can dynamically change their types in this language. Strings. Strings are important in many languages, and Python is no exception. Strings are thought of as a sequence of characters. That's nothing new. That's pretty consistent with many languages, such as C. One slight difference is how you can define the sequence of characters. You can do it by single or double quotes, so that is unique with Python. You may see examples on these slides with single quotes, and sometimes maybe you'll see me using double quotes. Whatever you have on the left, you put on the right, but a string is defined by using quote marks, double or single. Don't mix them up. If you start with a single quote, finish with a single quote. Concatenation is possible by the overloading of the plus sign, in the sense that if it recognizes 2 strings on both sides of the plus, that will be interpreted as concatenation, as opposed to an addition of 2 integers or an integer and a float, for example. And then there's the ability to pull off subsequence of characters with the slicing operator. And the slicing operator is the colon. And so this very simple example that we have here is an illustration of defining two strings. One of them will define the string variable we'll call str1. It will store the string Fred. And then the second string variable str2 will define Wilma. I guess I'm thinking of the Flintstones here. And so I have two string variables that are defined with those two different strings. And then we execute this print command to illustrate the use of not only print, but the concatenation operator plus. So what we've got here is we're trying to print this for the str1 string, which is Fred, concatenated with a string, which is basically a blank followed by the word A and D and followed by another blank. So in this case, what you've got here is 5 characters in the sense that you've got a blank, A and D, and then another blank. So again, if a space character is a character, don't forget that. And then we concatenate it again, the second string str. So I think if you look very carefully, you can see what we're doing here is that we're trying to basically print out the first string, in this case, of course, is Fred, and we would print Fred, and then there would be a space, and then the 3 characters A and D, followed by another space, and then we would have the second string, which is Wilma. So that's what the first print on this slide would produce. Okay, an example of concatenation. And again, that my underline there means space. Now, the second print is an illustration of slicing. Again, your ability to pull off a subsequence of characters from a string can be extremely useful in many applications. But you have to be a little careful how you interpret this colon notation, and so I want to go through this with you. And then the way we interpret it is consistent across all the data structures where we will do slicing. And so in this case we're doing it with strings, but in a little bit you're going to see me talk about the same thing with slicing, but with what's called a tuple. So we have a string 1 which stores Fred. It's a sequence of 4 characters, capital F, R, E, D. And this particular slice here of that string is indicated by a starting position of 0. Right? So what that means is you think of, well, what is the character in position 0? And of course, it's what you'd expect it is. It's the capital F here. That is in position 0, and of course, you would expect the R to be in position 1, and then E is in 2, and then D is in position 3. But what the slicing operator colon here is indicating is that you would start, this says start in position 0, and then go up to but not include position 2. Some people would call this more like a boundary. Again, let me say that again. That means you go up to but do not include that particular position. So in this case, if I start at 0 and go up to but don't include 2, I would only cover 2 positions. Okay, so that would mean I would cover 0 and then 1. So the only output you're going to see in terms of this slice is the capital F and the little r. So again, we think of the second operand, you could say, for the slice, or what comes to the right of the colon, is a boundary index. Okay, it literally means up to but not including. Now, another property of strings, as implemented in the Python language, is that strings are what we call immutable objects, and they have fixed length. So strings have fixed length. You can't change the length as you define it, and they are immutable. Immutable, of course, means cannot be changed, and so therefore they can't be modified by some other assignment statement. And this is a classic example. Suppose at the Python interpreter prompt we were to find a string called S, and we were to assign it this sentence, my name is John. And of course, keep in mind that there are some blanks in there. So it's certainly got the 4 words, but there are these 3 blanks that are included in that. So those are each characters in the sequence. And then what's illustrated next is an attempt to define in position 0, so the character in position 0, to set it equal to capital T. Of course, in the original string, we are looking at the capital N is in position 0. That is the 0th character in the sequence. What happens, as indicated here in the comment? Well, what happens is you would definitely get an error. And the interpreter hopefully would tell you in the message, and we'll see examples of this later, that the string is immutable. It's not allowable. Such assignments are not allowable. Strings are not immutable. Other data structures are mutable, but these are not. So let's move on to another particular data structure. This is the tuple. Similar to strings in some way, but a little bit different. Gives you a little bit more flexibility. This is a sequence of arbitrary objects of various different types, and yet still supported by similar string operations. What's important to realize is the delimiter for tuples are parentheses. So when you see parentheses, you'll be thinking of tuples. Here at the command prompt for the interpreter, we're defining a particular tuple called a record. And again, this might illustrate information about a human's record or a person's record. And you can see clearly here that what we've got here is a tuple with 3 basic objects to it. One is a string, looks like a last name, followed by a first name. And then what's interesting here is we actually have a tuple within a tuple. So this last object, the 3rd object in the record, is actually a tuple itself, and it's representing a date. So it's 3 integers being used to represent a date, which is very common when you think of filling forms out. So that probably represents, and most likely, May 15th, 1975. So again, the objects are separated by commas, so that's very important to realize that you separate the objects by commas, and you can have as many as you want, and they can be all different sort of types, integers, strings, floats, and so forth. Again, very, very useful if you're thinking sort of database kind of applications. And what's really cool is what you can do is you can immediately, having defined the tuple, you can assign labels to the different objects. And that's exactly what this next line is doing here, is we're now assigning a label to each object. And the assignment is done in order, so it matters what comes first in terms of the object that you define and the corresponding label. So in this case, last is going to be associated with Doe, first is going to be associated with John, most likely the first name, and this 3rd tuple, which we said is a representation of a date, in this case it'll be a birth date. And we'll call that label B-date. Right? So basically what the interpreter is now doing is got the capability of creating variables, or I use the word label, but you could say variables now, are associated with each part of the tuple record. So if you were actually to print first, right, which is not, in this case, not the first object, it's actually the 2nd object in the record. It's associated with a first name, you would get the output you'd expect. You're expecting to get the first name of this person, which corresponds to the 2nd object in the record tuple, and you'll get John. And then what you see in the next line is assigning another variable. In this case, we're going to call it, like birthday year, or let's just say B year, to be within the B date object, which itself is a tuple, the information or the data, let's just say that's in position 2. And clearly if you go to this particular tuple, which is being, occupying the third object position of record, the 5 is in position 1, the 15 is position, 5 is position 0, 15 position 1, and 75 is in position 2, which clearly is a representation of a year. So now what we can do is we can say, well, the birth year is actually B date bracket 2. It's the object within, it's the object in position 2 of the birth date tuple, which lives inside record. And again, how does it know what B date is? Because it got the position of B date from where it lies in the record tuple. So it's really nested and very, very cool in that way that you can have tuples within tuples. And then, of course, what you'd expect if you were to print B year in this case is you would get the integer 75. If we just keep that example in mind now and then just illustrate the fact that I mentioned earlier that even tuples have arbitrary object types and things, but they do share some of the similar functions that string does, that you can actually concatenate things. In this case, you could define a variable name to be the object in position 1 of record plus a space plus the object in position 0. So if you think about, again, what the meaning of those objects are in terms of their position, Doe is in position 0, John is in position 1. So this is a representation of printing, let me go back, I'm sorry. This is a representation of printing the first name John with a space, I'll indicate it like that, followed by Doe. So again, we're concatenating the space between the other two objects. And that's what you would get for print name. Now, if you were to access a particular object out of the record, in this case indexed at 0, again, you know what that is. We've already said this. That would be fairly simple just to get the last name. So this second print will do nothing but just print Doe. Now the next one is kind of special because now we're getting into that slicing capability, which we saw earlier for strings, but now we're doing it inside tuples. And again, the objects could have different types and so forth. So keep in mind what we said before in terms of how the slicing works with the starting position and then the boundary. So what print record 0:1 it turns out is not the same output as print record 0. This is not a slice up there. That's just a particular object. So for this particular slice, you would get a tuple back. So it will actually print a parentheses to indicate that you're going to get a tuple. It would give you that first object, which is the string Doe, followed by a comma. But because the boundary index here is 1, it can't include the 1, so it just stops and prints a right print. And that may seem strange, but you may want to play with that a little bit to get used to it. But this is an illustration of a tuple with one element. Okay? There's only one element in the tuple, and it's followed by a comma. That's the default. Now the second one actually may make more sense in the sense that, again, this is a tuple which starts off in position 0, which means it would print what it sees in position 0, which is Doe, comma, and then the boundary is 2, which means the boundary is the birthday tuple there, 5, 15, 75. It's not going to get there, but it would get through John. So this would print a tuple. In other words, you would have parentheses, and then inside the parentheses you would have the string Doe and then the string John. So we've had strings and tuples, and now we're going to lists. Lists are very similar to tuples, but they are mutable, and the elements and the length can be changed. And that's very important when you think of the meaning of a list and how you've thought of a list and use the sort of list data structures in C and C++. So first thing right off the bat with the interpreter here, you're noticing we're going to define a variable called a list, and it's going to get, notice, square brackets. So keep in mind, strings, single quotes, double quotes, tuples are delineated by parentheses. Lists are delineated by square brackets. Very important, okay? Have to keep this straight. The items within the list separated by commas, and so here's an illustration of a list of 3 floats, okay? Again, because I literally put 0.0, the interpreter will assume that those will occupy a floating point representation in memory. If you're wondering if I had put list equals bracket 1, 2, 3, that would be a list of integers, okay? Because again, it will literally interpret if it has a decimal point or a period there, then it knows to create floating point representations. So, square brackets for list. Lists have really nice built-in functions with them, and they're accessible through the dot operator. In this case, that if you wanted to quickly add another element to the list, you can use the built-in function associated with the list type. So you would just, the interpreter knows that this variable list is a list itself, so it can use the append function for list, and you essentially use it by the dot operator. So you would say list dot append, and then give it whatever you want to append, and then when you printed that list, which indicated here, it's what you would expect. If you printed it, you would have a 1.0 followed by a 2.0 followed by a 3.0. That should have been a comma there. I'll correct that. And then you would have a 4.0 here. Okay. All right. So that's appending. And another nice built-in function is insert. In other words, you'd like to insert something into the list. And this is a built-in function for all lists. And again, whatever the variable of type list is, you would name it, then put dot insert. This will be the position that you're trying to insert it into. And then the object itself that goes in there, in this case 0.0. Right? So if you were to print, if this was in the same program, the list now has 4 elements. It started off with 3, and now you have 4, and now you do the insertion, and you would expect that, okay, if I insert something at position 0, that means it's at the very beginning of the list, and that will be put in there, and then everything else will follow. So you'll have 0, then 1.0, and then 2.0, and then 3.0, and then 4.0. And that would be the end of your list. Okay. So you would have 5 elements in that list. If you needed the length of the list, again, it's very easy to get that in Python. There's a built-in len function for length. Very, very nice. Especially as you're dynamically changing and adding or deleting, and you need to know how long the list is. There's no need to use any type of loop structure. You simply could access it by just passing the list, the name of the variable, in this case list, to the length function. And if I printed the length out for this particular list that we have here, then what we would have is just, what we would have is just 5. So it would print a 5. Okay. Now if we, again, think of slicing, and now we're doing it with list objects in this case. Here's an illustration of mutating, or it's changing. Lists are mutable now. Strings weren't, but lists are. And this is saying that I'm going to change some of the interior of my list, and I'm going to start in position 1, and I'm going to go up to but not including 2, and modify the sublist.